Okay, good day. This is AP Calculus Summer Review. I am Mr. McCully, and today's presentation is on piecewise functions. So let's get right to it. All right, piecewise functions. We're going to be graphing piecewise functions, and we're also going to write piecewise functions based on given functions of line segments and probably other functions as well. So before we get into it, let's read. We haven't done this since Algebra 2, so let's review here. Piecewise function is a function that has multiple subfunctions for different pieces of the main function's domain. So when I say subfunctions and I say pieces of the domain, I'm talking about two different things. When I talk about subfunctions, this particular function f has three subfunctions. It has the subfunction x squared minus 4, the subfunction 0, and the subfunction negative x squared plus 4. It is broken into three pieces of the domain. For the values of x that are less than negative 2, we are going to plug all of those values into this first subfunction. For the values of x that lie between negative 2 and positive 2 inclusively, we are going to graph 0. And for the values of x that are greater than 2, we are going to graph the function negative x squared plus 4. So these determine where the domain, where on the domain each subfunction is in effect. Now, what does that mean? Well, I have another one right here. So let's do that. So what this says here is you almost read it backwards. You almost consider the domain part first. So what I'm saying is that for the values of x, so I'm just going to highlight here just real quick, that are less than negative 2. So when I'm plugging in values on this side of the x-axis, I am going to be using this first rule. And then when I plug in values from negative 2 to positive 2, I'm going to use this constant rule 2. And then when I plug in values for x that are greater than 2, I'm going to use this last rule right here. So let's get to it. So again, now since this first one is not including negative 2, it's everything up to but not including negative 2. What I'm going to do is I'm going to plug in this negative 2. Negative 2 squared is 4, minus 4 is 0. So at negative 2, I would have 0, but it doesn't include 0. It includes everything up to but not including 0. So I'm going to put a little circle there. Now I know that this is a parabola that opens up, and if it was a normal parabola, not a piecewise function, just a normal parabola, I get a graph that goes down through 4 and then back up. So I know it's a parabola, and so I'm just gonna plug another point that's inside this part of the domain, this piece of the domain. So if I chose, say, let's say negative 3, well, negative 3 squared, negative 3 times negative 3 is 9, minus 4 is 5. So at negative 3, 5, I have another point that's part of a parabola. So what I'm going to do is I'm going to draw this in as if I were drawing in a parabola. I'm going to get that. Now, this is going to go on for forever out to negative infinity, and it's going to go off my graph, but that's okay. Now, the second piece of the domain is from negative 2 to positive 2. Again, we are graphing from here to here, and we are using this subfunction, positive 2. Now, the subfunction positive 2 is just a constant, and it is positive 2 wherever, and that is a horizontal line. So I'm just going to draw in a horizontal line from negative 2 to positive 2, and this is inclusive, so I'm going to include a closed dot right here and also right here. Notice that this is not a continuous curve, that we do have a break. Now, is there a way to get it so that it comes down and touches and this dot would fill in? Absolutely. If I use the original function right here, this 0 function, then my constant would have been right here. But I did want to show that you can have breaks in it. Now, finally, I want to graph for values of x that are greater than +2. So from here towards positive infinity. This time though, let's see, I want to undo first. Let's undo this. This time though, my first value I want to pick is again at 2, because that's a point where we change. So we're going to have to graph all of these points where you change from one piece to the other piece. And so when I plug +2 in, +2 squared is +2. Make it negative. +4, I'm going to get 0 again. But again, because I am not including 2, it's up to everything up to, but not including 2, I have this open circle. So now I want to pick another point, say 3. All right, so 3 squared is 9, make it negative. +4 is going to be -5, so I'm going to get a point down here. And again, I know that this would be a parabola that opens down and goes through the y-axis at 4, but we're not drawing that because we have another subfunction for that piece of the domain. All I need to worry about is to make it look as if it were a parabola. Remember, a parabola gets fairly steep there. So this, even though it looks kind of ugly, that is our graph. And that's basically what I'm going to ask you to do. Now again, do I have to have these breaks? No. I could, if I were to change this one right here to say, let's say it were 0. Well, if it were 0, then all of these this piece would come down and be a constant piece 0, and these dots would fill that in. So you can have a lot of different things going on. You can have jumps, you can have breaks, you can have sharp turns, you can have continuous curves with piecewise functions. But again, what you want to do, break it down. Say, where on the graph am I going to be graphing my subfunctions? What piece of the domain do I have to use to do the subfunctions? All right, so the second thing I want to do today is I want to talk about actually writing some piecewise functions. So when you're writing a piecewise functions, I gave you a couple steps here to think about, and you can refer to this when you're doing the practice work. But what you're going to want to do first is you're going to want to find the places in the domain where the function changes. So basically, if we look back at this original one, this function changes at -2 and at +2. It changes at -2 to this function, and then it changes at +2 again to this function. So that's what you want to do first. And then once you found those changes in the functions, then you want to write an equation that fits all of the pieces. And then once we're done, we're going to put it all together and write a function that includes all of the rules over their appropriate domains. So let's talk about this here. Here is the graph that I'm trying to do a piecewise function, and they tell me at the beginning that it is a bunch of line segments, so I can consider all of these things to be straight lines. And so I want to talk about where my domains are. Well, this one is similar to the last one in that I see it has a change from going up, and then at -2 it changes to a constant, and then at +2 it starts going back up again. So here's what I want to do. I want to first, we're going to talk about f of x. I'm going to do some work down below, but I'm going to make this my final. And I see 1, 2, 3 pieces, so I'm going to draw this in as if I have 3 pieces. I'm going to give me some space. And so in this one, this first piece that as I go from left to right is coming up, I am going to say that the domain for this subfunction is from -infinity to -2. So we're talking about values of x that are less than -2. Now, could have I put the less than or equal to there? Sure, wouldn't have been a problem. But if I do, on the next one, you got to make sure that you have it just a greater than or a less than. All right. Now, this second subfunction right here, its piece of the domain is from -2 to +2. So we're going to talk about that piece of the domain from -2 has to be less than or equal to this time. And I'm just doing it this way because, again, I want to fill in that point. So values of x less than or equal to +2, and that way we'll keep it consistent. And then finally, this last piece, its domain, goes from +2 to +infinity. So we're going to write that from values of x that are greater than +2. Now let's do the easy one first. Obviously the constant line, that's the easy one. We're going to do that one because this would just be x equals 2. So this middle function is just the constant function. Its subfunction is just x equals, or f of x equals 2, because any value for x you plug, -1, it's 2. Now, for these two, these are obviously, since they told us it was line segments, they're linear equations. So we want to find a way to quickly find some easy linear equations. So we're going to use that point slope form that we talked about in the last section. And here's what I'm going to do. I'm going to say that this is a point right here, and since it's a line segment, I'm going to guess that it is at -2, +2. And then I have another point right here at -3, 0. So here's what I'm going to do. I want to use that point slope form. And if you remember from earlier, it was y minus y1 I screwed that up. Y minus y1 is equal to m times x minus x1. Now, here's the thing. I got a slope here, and if you remember, that slope function is m equals y2 minus y1 over x2 minus x1. So I'm actually just going to plug that in for m, and I'm going to do it all in one step. So I'm going to call this thing right here, this is my x1 and my y1, and I choose that as my 0 because I'm gonna get to skip a step here. We have that 0, just looking ahead. So it's y minus 0 equals, well, the slope equation, or the difference in y, so 2 minus 0 over, let's see here, 2 minus 0, and so I need -2 minus -3, and then it's going to be x minus -3. So in one step, I'm going to try and simplify this thing, and I'm going to say y minus 0 is just y, 2 minus 0 is 2, -2 minus -3 is +1, so this has a slope of 2, and that makes sense right there, because if you go up 1, 2, right 1, that's a positive slope of 2, and then I have x plus 3, because a negative, subtracting a negative is like plus a positive, or adding a positive, and then I'm going to finish it out, y equals 2x plus 6. And that looks okay too, because if I follow that pattern up, check it out, it's going to go through 6. So I think we're good there. So what am I going to put for this subfunction for the piece of the domain that runs from -2 to -infinity? Well, I'm just going to put in this right-hand piece. So it's just going to be 2x minus 6. All right, now to finish it off, I'm going to do this last piece right here. And again, I just need to pick 2 points. So I'm going to pick this point right here, and I'm going to call it 2, 2. And I'm going to pick this point right here, and I'm going to call it 3, 4. And so we're going to come back down to here. I'm going to use the same equation that we did right here. And we're going to go y minus, well, I got to decide. We're going to call this x1, y1 right there. So we're going to go y minus 2 is equal to, well, I got to calculate that slope. So let's see, 4 minus 2. There's the difference in the y's. And then 3 minus 2, 3 minus 2. And then we're going to go x minus x1, which was also 2. And so let's see here. I end up with y minus 2 is equal to, well, let's see here. 4 minus 2 is 2. 3 minus 2 is 1. So I get a slope of 2. And I get 2, or excuse me, I'm going to get x minus 2. And so y equals, I distribute, so I got 2x minus 4. Add this 2 to both sides, and that gives me a final answer of y equals 2x minus 2. So this is the subfunction that fits this linear equation. So we end up with 2x minus 2, and it looks like I have a copying error, doesn't it? Well, I said plus 6 here, so let's make this plus 6. I'm sure that some of you were yelling at me that I screwed that up, but I'm glad I caught it. That way I don't have to give any bonus points for anybody catching my errors. And it looks like we are finished. So this is the piecewise function that will graph this particular set of line segments. And that's all I have. All right. That's it. That's the end for today. Kept it down to only 15 minutes. Not too bad. Star Wars fun fact of the day. A lightsaber is so hot that it instantly cauterizes a wound as it passes through your body. So if you get cut by a lightsaber, you won't bleed out. Well, that's all I got. Again, if you have questions or if you think I made a algebra or arithmetic error, please leave a comment in the description below. And as always, I hope you're having a good summer. That's it. Goodbye.